My name is Larry Hawkins, and I'm Director of Technical Marketing and Systems for Richardson RFPD. My presentation today is on RF integration, but before I talk about that, I want to introduce you to Richardson RFPD. Richardson RFPD is a worldwide distributor for RF and microwave components. If you're interested in getting a broad view on RF and microwave components available in the market today, please talk with one of our representatives. We cover components with frequency ranges from DC to 110 gigahertz and components from high-speed converters and DC power to antennas. My presentation today is regarding RF integration, specifically focusing on size, weight, and power. An analogy to RF integration might just be modeled after the VW bug. You have those interested in just putting more stuff in a chip, those interested in making their customers' lives easier, those that want things adopted for their application, those interested in more performance, military versions, and those that marketing gets a hold of. On a more serious note, Analog Devices has a line of integrated transceivers that focus on high performance in a very small size. And I'd like to focus on the ADR-V 9002, a newly announced part that can be used for cellular infrastructure applications, but is a first integrated transceiver focused on other applications. As you can see, ADI's high-performance integrated transceiver portfolio started with the AD9361 and its variants. And it was followed by other parts that could be used for many applications, but were more focused on cellular infrastructure applications. The ADR-V 9002 is the first high-performance integrated transceiver that can be used for cellular infrastructure applications, but it focuses on everything else. Some highlights include decreasing the frequency coverage down to 30 megahertz, and its focus on more narrowband modulation signals. Because it was made on a 28 nanometer CMOS process, it's a very low power part. The ADR-V 9002 has 2 transmit channels, 2 receive channels, and 2 synthesizers that can be muxed to any combination of the transmit and receive channels, allowing it to be used for FDD or TDD applications. Or you could even use one of the receive paths as a sniffer to see which frequency bands are not being used while the rest of the system is turned off, and then switch the whole system to the empty frequency band. It has various low power modes and the ability to do fast frequency hopping and DPD. I believe the first open market digital pre-distortion that works for very narrowband applications. It also has a SPI or LVDS digital interface, allowing it to be used with an inexpensive processor or FPGA. The ADR-V 9002 also has various digital functions like digital down converters and FIR filters. And multiple ADR-V 9002s can be synced together for MIMO-type applications. Eval platforms and samples are available now, and the part will release at the end of 2020. In our IMS virtual booth, NextGen RF is showing the receive performance of the part, including showing the ability to receive and demodulate both narrow and wideband signals. For example, they'll be showing how the ADR-V 9002 can be configured for wideband and is still able to support narrowband decoders. We'll also be showing the performance of an RF front end connected to the ADRV 9002. This front end has a 45% efficient 9-watt PA for the transmit and a 2.5 dB noise figure for the receive. Also in our virtual booth, we'll be showing various system-level applications like this high-performance enterprise SDR platform from Vanteon. Thank you for your time, and I look forward to seeing you at our booth.